Dear students, welcome to the next lecture in this lecture series on signals and systems. So, in the last lecture, we started the topic of convolution and we just solved one problem that was introductory problem based on the convolution. Now, in this lecture, we will try to solve some more problems on the convolution. Okay, so first of all, we just want to write the different steps which are required in evaluating the convolution which we discussed in the last class. Okay, so steps for evaluating the convolution. So first step should be to draw right and write first of all equations and draw sketches for xt and ht. Okay, so these are already should be given to you in the problem itself. So first of all, you should write the equations and draw the sketches for these two functions xt and ht. Okay, then in the next step, write equations and draw sketches for x tau and h t minus tau. So you already got the expression of xt. So in this expression you just replace the variable t with tau. So you will get x tau directly from ht, and similarly ht minus tau have to be obtained from ht. So in this you will require the basic operations on signals which we have studied in the first unit. Okay, and then the last step should be to perform integrations to calculate or to find yt for all the values of t. Okay, so the convolution integral we have already defined in the last lecture. So the output of that convolution integral, which is yt, that you have to calculate for all the values of t. Okay, so these are the basic steps which we generally follow in evaluating the convolution. Now we will imply these steps in solving the problem. Okay, so the first problem is xt will be given as e raised to the power minus mod t for all the values of t, and ht is given as e raised to the power minus 2t for t greater than equal to 1, and it is 0 for all the values of t less than 1. Okay, so the question states that you have to find the convolution of these two continuous time signals. Okay, the question is find the convolution of two continuous time signals, and the continuous time signals are already defined above. Okay, now to start the solution, uh, we will generally follow the 3-step procedure which we have just discussed in the previous slide. So you already know by the definition of convolution which is discussed in the last lecture that convolution is defined in this way: xt convolution ht, which is further expressed in the form of convolution integral, that is x tau h t minus tau d tau. Okay, so what should be the first step? That you have to write equations and draw sketches for xt and ht. Okay, so equations are already given to you. You can just simplify them further. So xt will be e raised to the power minus t for t greater than equal to 0, and it will be e raised to the power t for t less than 0. And similarly you can write for ht will be, it is already given that it is e raised to the power minus 2t for t greater than equal to 1, and it is 0 for t less than 1. So if you try to plot the sketches for it, so xt will look like something like this. I will try to plot it. So it will be something like this. This will be the xt sketch. This amplitude will be 1. So on the left hand side the graph will be e raised to the power t, which is for t less than 0, and on the right side the graph will be e raised to the power t, which is for t greater than 0. Okay, so this will be the plot for this xt, and similarly if you plot for ht, you will have something like this, okay. So this will be ht, this is t, this value should be e raised to the power minus 2, okay, at t equals to 0, and this will be 1. Okay, now we proceed to the next step as step 1 is completed. Now what you have to do in the next step is to write equations and draw sketches for x tau and h t minus tau. Okay, so first you just try to write for x tau. This is very simple. You just have to replace the variable t with tau here. Okay, so this is it. This will be the x tau, and now for evaluating h t minus tau from ht, you have to know the basic operations which we have discussed. So you know that a precedence rule has to be followed for it. So from ht you should first obtain h tau just by replacing t by tau, and then after it you should apply shifting in it. So this small t will be the shifting factor for it, and then after shifting you can just time reverse it, okay, to get minus tau plus t. So when you will obtain this minus tau plus t, so this will be same as h t minus tau. Okay, so in this way you can just obtain h t minus tau from h tau. Okay, so from h t you have obtained h t minus tau by following these intermediate operations. Okay, so your ht minus tau will be minus twice of t minus tau for t minus tau greater than equal to 1, which means that tau should be less than t minus 1, and it will be 0 if t minus tau is less than 1, which means that tau is greater than t minus 1. Okay, so if you now plot these two, so x tau will be same as xt, except that there is a change in variable. So this is the same graph as we had drawn in the previous slide. So this will be x tau, the variable is tau here, this is 0, this amplitude is 1, and when you will plot ht minus tau, so this will come something like this. So this is t minus 1. So you can also obtain this waveform just by looking at these basic operations, that obviously in the waveform of ht, first you have just changed the variable, and then after changing it you have applied a time shifting equal to this factor t, and since this is tau plus t, so the shifting will be towards the left hand side, and after time shifting it you just time reverse it. Okay, so just by your previous knowledge of this first unit, you can obtain this ht minus tau waveform from ht. Okay, now the case is that there can be two different cases. Now what are those two different cases? The first case can be if this t minus 1 is less than 0. Okay, because shifting will depend on the value of this shifting factor t. So if this t minus 1, which we have written over here, if this t minus 1 is less than 0, which will mean that this t is less than 1, then I will just draw a figure which will combine, which will have these two signals. Okay, so this is the waveform of that x tau, this is the waveform of x tau, and in the same figure I will now draw the waveform for ht minus tau. Let me just choose a different color for it. So this should be something like this. Okay, so your this waveform is ht minus tau by taking this case, if this t minus 1 is less than 0. Okay, so this, if t minus 1, if it is less than 0, so your waveform will be something like this. Obviously it will be towards the left hand side of this origin. Okay, so the intersection of these two waveforms, so you can see here that if I just shade this region, okay, so this you can see is the common region between these two waveforms. Okay, what you have to do, you just have to perform the integrations over this common range. So now you can look from this figure that the two functions will overlap for the range of minus infinity and between t minus 1, isn't it? So the shaded interval actually, if this is the tau and this is 0 and this is t minus 1, so from minus infinity up to this t minus 1, the two waveforms have a common area. Okay, so you just can perform the integration which is in step 3. Okay, so we have already started the third step, so you can just write here that we have started the third step. I forgot to mention it. Okay, so the third step was to perform integration to find yt for all values of t. So in this third step you just have to take both the cases. So first case was this, so you can perform the integration for it for the common region minus infinity to t minus 1, and this is e raised to the power tau, and then this is minus 2 t minus tau d tau, and from t minus 1 up to infinity, although this signal is present but the second signal is not present, so it will be 0. Okay, so you can just simplify this from minus infinity to t minus 1 e raised to the power 3 tau d tau plus 0. So this is 1 by 3 e raised to the power t minus 3. Okay, so this is for t less than 1. Okay, now you have to take the second case as well. So let us take this second case as well, case 2. Now what will be case 2? That if this t minus 1 is greater than 0, from which you will get that this t can be greater than 1. Okay, so again in that waveform, if that is in this ht waveform, or I think in this waveform ht minus tau. Now if this t minus 1 is greater than 0, so this is the second case which we have taken here. Okay, so let us just first of all draw the waveform. So this will be the same x tau as we have drawn previously, and the second waveform will be, I will draw it with a different color. Something like this. Okay, now you can see that the common region between these two signals have changed, and now the common signal can just be denoted by, let us again draw the shaded region. Okay, so this is the common region. Okay, so if this is again this is t minus 1, okay, this is 0, and this is the same signal ht minus tau. So again in the same figure I have tried to show both these figures. So you have to know the basic or the common region between these two functions, that is the overlapping period of these two functions, and the overlapping period can be seen from the figure as again minus infinity to t minus 1. So now you have to perform the integrations for these two. So from minus infinity to 0, this will be e raised to the power tau, and then the second function which is e raised to the power minus twice t minus tau d tau, plus from 0 to t minus 1, because on the right side of 0 this x tau is changing. On the left side it is e raised to the power tau, and on the right side it is e raised to the power minus tau. Okay, that is why we have taken the different intervals. And then after t minus 1 up to infinity, there is no need to write, although I just tried to have some more understanding. This ht minus tau will be 0, so there is no meaning of this integral. You can just write it to be 0. Okay, so if you just simplify this, so this will be minus infinity to 0 e raised to the power 3 tau d tau plus 0 to t minus 1 e raised to the power tau d tau. So this will be e raised to the power minus t plus 1 minus 2 by 3 e raised to the power minus twice t for t greater than equal to 1. So you have got two different parts of this solution, two different cases you have considered. One part you have got for t less than 1, which was this, and the second part of the solution for t greater than equal to 1. So in the final solution you have to combine these two results. So now you can combine it. So it will be e raised to the power minus of t plus 1 minus 2 by 3 e raised to the power minus 2t. This is for t greater than equal to 1, and it is 1 by 3 e raised to the power t minus 3 for t less than 1. So this is your final solution or the convolution of two different operations. Okay, you can also try to plot this. So just by taking the values at different points, this is simple to plot. I will draw the approximate plot for this. So this should be something like this. So this is how it will look like. You can draw the exact plot by taking the different values. Okay, so this is 0, 1, 2, 3 and so on. Okay, so this is the final solution for it. Let us now try to discuss, try to solve one more problem based on convolution. The question is find the convolution of a rectangle signal xt. Xt is given as a rect t by 2t, and it can also be represented as a gate signal. From minus t to t and 0 otherwise. Okay, so the question is that you have to find the convolution of this rectangle signal xt with itself. Okay, now before starting the solution of this problem, let us quickly discuss this signal which is called a rectangle signal, or in short it is written as rect. So a rect t by 2t. So this is a signal which is represented in this form. So it has its limit from minus t to t. So the denominator of this function actually represents the width of the signal. So whatever is written in the denominator, that will be the width of the signal. Okay, so obviously this is an even signal, so it is called a rect signal, rectangle, or in short it is called a rect signal. So generally it is written in that form, a rect t by tau, and a is its amplitude. This amplitude is a. So if the amplitude is a and it is lying from minus t to t, then it can be written in this form, a rect t by 2t. Okay, now let us proceed with the solution. So the question was that you have to find the convolution of a rectangle signal with. So by definition, you know that yt is equal to xt convolution ht, which is integral minus infinity to infinity x tau h t minus tau d tau. Okay, so in the very first step you have to write equations and draw sketches for xt and ht. Okay, so this question can be framed in another way, that evaluate the convolution integral for a system with input xt and impulse response ht given by xt equals to ht equals to u of t plus t minus u of t minus t. Okay, so both these actually represent the same problem. The problem can be stated in two different ways. Either it can be written that find the convolution of the signal xt with itself, or it can also be said that evaluate the convolution integral for a system with input xt and impulse response ht given by this relation, a times u of t plus t minus u of t minus 2. So this signal a of u plus t minus u t minus t will be same as this rect signal. Okay, now come back to this first step, that write equations and draw sketches for xt and ht. So xt will be a for minus t to t, and it is 0 otherwise, and ht will be a. So obviously these two signals are same. Okay, and if you try to plot these two, so these two will look similar. So this will be xt from minus t to t, amplitude will be a, and ht will also have same variation, that is this is ht from minus t to t. Okay, now let us proceed with the second step. In the second step you have to write sketches and draw equations and draw sketches for x tau and h t minus tau. Okay, so x tau will be directly written as a. If tau is in between, this is tau, it is in between minus t to t and it is 0 otherwise, and similarly h t minus tau can be written as a for t minus tau greater than this it is in between the minus t and t. So this can be simplified to t minus t, and it is less than tau, and so this can be written in this way. This is t and this is 0 for all the other values. Okay, so you can if you plot this, x tau will be same. This is x tau. From minus t to t, the variable will be tau, and the second, which is ht minus tau, it can be shown in this way. This is ht minus tau, so this is t minus t, this point, and this point will be t plus t. Obviously you can apply your knowledge of time shifting and time reversal, which we have also discussed in the last problem. Okay, so this was the second step. Now in the third step, you have to perform the integrations, okay, to find yt for all the values of t. So again there can be different cases depending on this value of t. So for the first case, if this t plus t, that is this, is less than minus t, okay, that means this h is less than this value, so there is no overlapping between them, or it can also be simplified as t less than minus 2t. So if this is the case, that its right edge is actually towards the left hand side of this edge of x tau, so how will the signal look like? The signal will look like something like this. So this is x tau, and this is ht minus tau. Okay, so this is ht minus tau. It is in between t minus t and t plus t. So this point is t plus t, this point is t minus t, and this is x tau. This point is minus t, and this point is t. Okay, so you can very clearly see from here that there is no overlapping in between these two signals. So if you just evaluate the convolution integral for both of these, so you will get 0 for it, as there is no overlapping in between these two signals. Okay, now come to the second case. If this t plus t is in between the minus t and t, okay, that can also be represented in terms of t. Okay, now if you draw the sketches for it, now you try to draw it again. So this is x tau, and what will be ht minus tau? So ht minus tau will be something like this. Okay, isn't it? So this point, as this is t plus t, so this point is in between minus t and t. So these 2 points, this point is minus t, this point is plus t. Okay, So this is h of t minus tau, isn't it? So from here you can see that if you want to evaluate the convolution integral, so there is overlapping in between minus t to t plus t. Amplitude of both signals is a, so the answer will come as t plus 2t for this range. Now similarly there can be some more cases, like let's take this third case, that if the t minus t is in between minus t and t, or it can be written as in this way. Now again you can draw the figure. So x tau will remain same. This is x tau, okay, from minus t to t, and let us just write its limit from minus t up to t, okay. Now try to draw the second case. So h t minus tau will be like this. So this is h t minus tau for this case. If this t minus t, that is this point, that is its left edge, is in between this minus t and t, okay, so this point will be t plus t, okay. So you can just extend this axis. So now from here you can see that the overlapping, the area of overlapping is this, and in the previous case the area of overlapping was this, okay. So now you can just evaluate the convolution integral for this case, put the limits according to the area of overlapping. So this will come as okay, and you can take one last case as well, that if this t minus t is greater than t, or it can also be written as in this form. So if this is the case, then what will happen, this is xt and this is ht, this is x of tau and this is h of t minus tau, okay. So this point is t minus t, this point is t plus t, from minus t to t, okay. So this t minus t, that is this point or this edge, is towards the right side of this t. So from here we can see that there is no overlapping in between these two signals. So pretty straightforward it is, that the convolution integral for this case, for this part you can say the solution, will be equal to 0 as there is no overlapping. So these are the different cases which can be there in this problem. Now you can just compile all these different solutions which you have obtained for the different cases in at one place, so you will get the final answer as yt equal to, so it was 0 for t less than minus 2t, then it is a square t plus 2t in between this range, then in between 0 and twice t it was this, and then again it was 0 for t greater than 2t. Okay, so this signal, if you plot this signal, so the waveform will generally look like a triangular signal. The amplitude will be twice of a square t minus twice t to twice t. This is 0, minus t and t. Okay, so this signal can be sometimes represented in more compact form as twice of a square t del of t by 2t. So this represents a triangular signal. Okay, so this is called a triangular signal. So we use actually this notation del of t by 2t to denote the triangular signal that is of unit height centered around t equals to 0 and it has the base of length 4t. Okay, so whenever something like this is written, so it is representing a triangular signal that is of unit height, because the amplitude here is the unity. You can assume that there is a 1 written over here, so the height is represented by this factor which is unity here. So height, unit height centered around t equals to 0, that is the center, and base length of 4t. So this is length on one side, you can say. So overall length will be just multiplied by 2, that will be 4t. Okay, so if it is represented like this, that means that this part represents the amplitude of the signal. This is what is written over here. Okay, so this is your complete solution, and you can also write it in some more compact form, although this is not necessary, but just for extra information I am telling this, that this can be represented as in this form also. So the solution becomes more compact. So both of them are I think correct. Okay, so you can follow any one of these. So this is the final answer of this problem. This is all for today. We will try to discuss some more things in the coming lecture. Thank you very much.